All right. Let's look at your quizzes or worksheets or whatever the heck you want to call them. I'm just going to kind of run through them. I'm going to do a couple of them for you, kind of get you started. So this will be your quiz 4A. It's 2 pages. There it goes. You got 8 problems on this. Here's 4B. You got 8 more problems. Sorry about my dog in the background. He's an idiot. Yes, he is. So we'll run through, do a couple of these, get you started, get you in the right direction, get this crap done. A lot of it on your test, on exam 2. A lot of this stuff is going to be on your final. Let's get good at this game. It'll come in handy later. So I won't do number 1. I think you can figure that one out, especially once I do number 2. And there's always a host of ways to do these problems. I'm going to do it the shitty way first. I'm not even going to solve the problem. I'm just going to show you what's going to happen. And then I'm going to do it maybe the quicker way. This would not be a good idea. But sometimes you have to go the wrong way to find out whether it works. So don't be afraid of going the wrong direction with this. So 1 times 1 is 1. 1 times negative cosine squared. Cosine squared, cotangent squared. Times 1, then cotangent squared times negative cosine. So cotangent squared times negative cosine. Okay, oops. Is equal to. Alright. So then I'm like, alright, well, I don't know what to do, so maybe we'll just, that could change it to sine squared if you wanted to, but I just want you to see something is about to happen. Now we take cotangent squared, and that's cosine squared over sine, so times cosine squared over sine squared of. Typically when we run into something to the 4th power, we're like, why am I making stuff worse? This is going to get gross. You can clean it up and you can certainly solve it this way. But typically when I watch students run through and they try and go this direction, they get stuck. And you get frustrated. So I'm going to stop. If you want to finish that thing off, it can be done, but I'm not going to continue going that direction. I think it's a fool's errand to go that way. So like everything getting large and looking terrible like that, I'm like, maybe there's a better way. And it is. The fact that you have a 1 plus cotangent squared, and that's exactly that one formula. That's exactly that one formula. 1 plus cotangent squared of x is equal to cosecant squared of x. And we know that 1 minus sine squared of x, or 1 minus cosine squared of x, is equal to sine squared. So you can replace these 2 things right off the bat. It's going to be much, much quicker. Cosecant squared times sine squared. Well, they're reciprocals of each other. When you multiply reciprocals by each other, that equals 1, and 1 equals 1. There it is. I'll show the stuff. But it's 1 over sine squared times sine squared. Hiya. 1 is equal to 1. Beautiful. Let's go to the next. And just doing a few of them. Maybe some that we might want to catch some games. I'm kind of emphasizing a little bit of the identities right now, like more of the maybe more of the algebra, which I focused on in the first few. Secants and tangents go together, especially squares and all that. So here's a little game, and I'm going to mess with the right-hand side for no other reason than just choosing to go to the right-hand side. So let's just factor out a tangent squared. That's going to leave us with a tangent squared of x plus 1. But that's our identity. Tangent squared of x plus 1 is equal to secant squared. So we can replace that thing in. So there we go. All right. So that's secant squared. Cool. But this other side has nothing but secant. So wait, whoa, hold on. What if I do this? What if I, oops, don't do that. What if I subtracted 1? What's tangent squared of x going to equal now? Tangent squared of x is equal to secant squared of x minus 1. So we can take this and replace it in for tangent squared. Now what does it become? Oops. secant squared still hanging out over here. And now we replace this in with secant squared of x minus 1. We'll bring it in. Secant to the fourth of x minus secant squared of x. That's equal to this other side, isn't it? Bang! We did it. We did it. Now you could perform the same trick on the left-hand side. It's all the same game, just manipulating that. Tangent squared of x plus 1 is equal to secant squared of x. Or secant squared of x minus 1 is equal to tangent squared of x. Or secant squared of x minus tangent squared of x is equal to 1. Know all the different patterns. You get shortcut stuff. Because trying to do this one, turning everything into sines and cosines, yeah, good luck with that. Tell me how it works. Actually, that one, I don't know. Cool. They progressively get a little bit more challenging, but not so much. If you use your identities, I think this problem right here, if you use identities and stuff, maybe one identity, one spot, a little bit about fractions. Problem's really simple. It's like 2 steps. All right, let's look at 3. Let's see this little style. I'm going to show you just a shortcut through this one. It's just a quick shortcut, but before we do, if I want to add, actually let's do this. Make it 6 sevenths, and I want to subtract 2 sevenths. Doesn't this become 6 minus 2 over 7? Right? And then we call it 4 over 7. Yeah, I don't care what the number is. Let's go this direction. Let's think about this. That's your 6. This is your minus 2 all over your 7. Can't you break this into pieces? So what I'm saying is we could actually run this thing as cosine squared of theta over sine squared of theta minus tangent squared of theta over sine squared of theta. Breaking those fractions into 2 pieces. Alright, because this thing's just one thingy. You got 2 thingies over here. You got to break it up. So learn that trick. You can shortcut things. It's like that tough problem I was talking about. Might have a shortcut in it. Alright. So let's just clean it up. Cosine squared over sine squared is that cotangent squared. So we got the first one. Now the only thing we need to do is show that the next part is secant squared. That this needs to be secant squared. Cool. So let's change tangent squared into what it is. Sine squared of theta over cosine squared of theta. All over the sine squared of theta. That's sine squared of theta over 1. So what ends up happening is this just goes thwack, and disappears. You flip it up and look, but that's what ends up happening, and you're left with cotangent squared of theta minus 1 over cosine squared of theta. But come on. What's that equal to? So these are the games we got to be proficient with, all right? You don't need to rewrite this, but I don't know why. Just showing it. Hey, same thing. All day. All right, last one. Hey, do number 4, especially. Make sure you know how to do 4. Put that one on test a lot. I'm not saying yours is going to have it, but it's 6 and another good one. I'm going to tell you right now. 8's a beast. 8 is a beast. Ask your past peer. Maybe ask me in class. 8's a beast. So, have fun. I want to talk about number 5. I'm gonna bust myself right now. The first time I saw this problem, I thought it was broken. And I struggled. Now that I've seen it, I can't unsee it. It's actually very simple, but just know that your teacher didn't see how to solve this one immediately. I felt stupid. But let's just do this. Shoot, this whole thing is wrong. Oh, well, then I will have yours fixed. This is supposed to be sine squared. I just realized before I started. So this will be fixed on your quiz. I guess I'll have to go back through. So it's supposed to be this. 5 sine squared plus 6 cosine squared of theta is equal to 5 plus cosine squared of theta. So let me rewrite that in. Sorry about that. That's cool that I found that error here, and not after I've assigned it to you. So there's the problem. Let's just get this whole thing out of the way. So we have 5 sine squareds and we have 6 cosine squareds. Well, isn't 5 plus 1 equal to 6? Well, let's rewrite the 5 sine squared. But then going, wait, let's take that 6 cosine squared. Now, isn't it true that it'd be 5 cosine squareds plus 1 of those cosine squareds? Wouldn't that be the same thing as 6 of those cosine squareds? And take that 1 out of there because that's just some nonsense. Alright, cool. Well, look right here. 5 sine squareds plus 5 cosine squareds. If you were to factor the 5 out, and that would leave you with a sine squared of theta plus cosine squared of theta, plus that cosine squared of theta. That's just 1. That's equal to 5 plus cosine squared of theta. Can't believe I didn't see that as a teacher. Huh? Come on. Come on. So I like just showing this one, because once you see it, you kind of can't unsee it. So, of course, your problem will be fixed. You won't have that issue in yours. Hopefully there's no other errors. If there is, let me know. I like hooking up extra credit when you find my mistakes. I'm fallible, just like you. So let me know. Okay, I'll see you in 2-3.